everyone. My name is Antony. I'm speaking from Rio de Janeiro, Brazil. I will share my presentation with you. Okay. Now, so let me introduce myself. I am a PhD student in computer science in Pontifical Catholic University in Rio de Janeiro. And I am also an IT executive in BNDES, the National Development Bank of Brazil, one of the biggest banks in Brazil, where I lead the data engineering team. Today I'll be presenting this paper, Dynamic Multi-Agent Orchestration and Retrieval for multi-source question-answer systems using large language models. It is based on an LLM application developed in collaboration between BNDES and PUC-Rio, right? So as an IT executive, I am also a contract manager, specifically for IT services such as software licensing, database support, and other contracts. And I can tell you that there are a lot of tasks that must be done in the realm of contract management, not only by contract managers, but also by lawyers and administrative people. We have to manage high contract developments, and we have to search for information, search for relevant information in the contracts. On a daily basis, we have to find specific clauses, understand legal terms, and analyze jurisprudence. These are very time-consuming tasks. I mean, if you're dealing with one contract, right? But frequently, these people are dealing with several contracts at the same time. For example, if you want to analyze SLA or penalties clauses among all the database support contracts you have in your organization, well, these are very time-consuming tasks. You have to cross information, compare them, summarize them, and they are likely to be error-prone too. So parallel to that, we've been observing the evolution of large language models, and we started to think about using these models to enhance contract management. So we could use these models, for example, to search, to do semantic search for key clauses, generating summaries of complex contracts, and especially understand contractual language, because people beyond lawyers does not understand this language, so it will be very helpful if we have a model like this one, and they are trained on a vast data corpus that includes contractual documents. So what we really wanted to do was something like that, a user interface where the user can ask for information about contracts. So, for example, do we have any contracts to support our ETL platform? And the system answers, oh yes, there is a contract to support the ETL. The number is this one, the object is this one. And we wanted to engage in a dialogue, asking who is the supplier of this contract, or who is the manager of this contract. The manager of this contract is Antony Seabra. Does he manage any other contracts. So that's how we started. That's what we wanted to do. Our first approach was to use retrieval-augmented generation. In this technique, what you do is split the documents. This is what we call chunking. You split the documents based on some strategy. For example, you can split your documents based on a certain number of words or tokens. And then you go through an embedding process that transforms these pieces of text into vectors, and then you can store these vectors in a vector store. Okay, in our case, as the contracts have a uniform template based on clauses, right? It was very natural for us to choose the clauses as chunks. So every clause in a contract document becomes a chunk, and these clauses is what we actually transform into vectors, and they are stored in a vector store. When the user asks a question, this question goes through the same embedding process using the same embedding model, and we ask the vector store to retrieve the similar chunks based on some similarity algorithm like Euclidean distance or cosine similarity, and the chunks and the most similar chunks are returned from the vector store. This will be included. These chunks will be included in a prompt along with the question and prompt instructions. And this prompt will be sent to the LLM that will generate an answer, and this answer is presented to the user, right? So this was our first approach. The first version of this question answer system was based solely on this approach. The result was good, right? But we noticed a problem that is the difference between similarity and relevance. Vector similarity does not always capture context-specific relevance. So what I'm trying to say is that for some questions, and I'll give you an example, the vector store will not return the relevant chunks that answers the question based solely on similarity. So somehow we have to distinguish between similar and relevant chunks. So for example, if you ask, who is the contract manager of the contract we have with Microsoft? There are a lot of clauses, there are a lot of chunks that includes the term contract manager. And possibly the returned chunks will not answer the question, who is the contract manager? So we have to, there are a lot of strategies to manage these problems, to achieve a better result. And the one we chose was a very natural one for us, because we, as we are generating the chunks and converting them to vectors, we always know the source of the document, the number of the contract, the clauses, and these information becomes our metadata. So each chunk is tagged with metadata fields, allowing targeted searches. And this improved our accuracy in the answers a lot. I mean, when we started to use this metadata in the vector store, our answers to these questions that similarity does not uh, respond accurately improve it a lot. But there's another point I want to tell you is about contracts life cycle. Some information of the contract, they are not static, they evolve over time. So alongside document-based chunks, we have to incorporate these updates, and these updates are uh, registered in a database. So we have the documents and we have the contract's life cycle. For example, the contract manager can change the values of the contracts are changing every year. So we have to incorporate this data from the database and show this updated information in every answer that deals with this information. So our first strategy was to extract texts from the contracts database and pass them through the same embedding process and store these vectors in the same vector store. So we finished using one vector store to have all our chunks that comes from the PDF documents and the contracts database in the same vector store. So when the user asks for a question, the similar chunks are returned from these one vector store. And this was actually what enabled us to answer a question like this one. Do we have a contract with Oracle? Oh, yes, we have a contract with Oracle. Summarize this contract. So you can see that there is a portion of this answer that comes from the document. This is the object part. And there are a lot of information that comes from the database, right? The managers, the manager's location, for example, the situation of the contract. So we started to be able to mix information from both the document and the database, right? But obviously there is a problem with this approach because we have to prepare these text extractions. So we move it on to a text-to-SQL technique. Text-to-SQL allows for a direct access to a database, and with this technique, you can convert natural language to SQL commands, right? So when the user asks for which contracts end by the end of 2024, well, this question, this natural language question, is converted to the SQL command you can show. This is a select statement, and actually, this select statement is executed in the database, and the data returned from the database is sent to the LLM that will prepare the answer, right? This technique, if you want to use this technique, you will have to use only your database schema. You don't have to use you don't have to access your data to convert the question to the SQL statement. You only have to present the database schema, and as the SQL statement is generated, it is executed in the database. So the data are returned from the database and sent to the LLM that will prepare the answer. With this technique, we were able to access the database directly, and that this was a very good improvement in our system. So, for example, this list is generated with a direct access to the database. So we finished with this multi-agent architecture. So we have a RAG agent and a SQL agent. There is a halter agent that will decide whether to send the question to the RAG agent or to the SQL agent, or both of them. The retrieved data will be included in the prompt generation that will be sent to the LLM. Once the LLM answers the question, there is another halter engine that will verify, that will check the data returned from the LLM, and we'll check if it is a tabular data. If it is a tabular data, then this data will send to a graph agent. It's a plotly agent that will generate a graph. So you can finish with a graph like this one, where you have the number of contracts per contract manager show in a graph, right? So a few words about our implementation. We use it PyMu PDF to process the PDF documents. I can tell you that this was a very time-consuming phase in our project, because although the PDF are uniform documents, you can have differences when you try to read these documents. So you have to manage, you have to be able to treat these differences. The chunks, the vector were stored in a ChromaDB. It's a very light vector store, a vector database. We use it. We use the Streamlit framework to build the user interface. It's a very easy to use framework. And our backend was composed by Python and LangChain. The LangChain framework is the one that integrates the user interface with the completion model. We use all the models from OpenAI. We started to use the GPT-3.5, then we moved to GPT-4. And for embedding, we use the TextDaVinci 02 to process the chunks and store in the vector database. As I told you, at the beginning of the project, we established a quality metric, and this metric was based on direct questions and indirect questions. The direct questions were the ones that can be answered from the PDF documents. And as you can see, we have 95 or more % of accuracy in these questions. And the indirect questions are the ones that are answered by the database, or both the database and the PDF documents. These are what we call the indirect questions. We have a good accuracy, actually too, but we have to improve some of the questions that are not being responded correctly. So to conclude this work and this presentation, the system is in production. The system is running at BNDES. Users are very satisfied. We are able to have a good accuracy in direct retrieval. We have improved accuracy with text-to-SQL. And the multi-agent architecture has a lot of benefits for our implementation. What we wanted to do next is to enhance metadata tagging, for example, to have a date metadata, so we can store the history of the contract, even in the documents. And we have to expand and improve our accuracy on indirect queries. And what we are doing at this very moment is implementing user feedback integration with thumbs up and thumbs down icons check. So we are able to check the incorrect answers when the user takes these answers. So thank you very much. Thank you for having me today, and I'll be glad to answer whatever questions you have. Thank you.